All right, let's take a look at the section 11.5 homework. 11.2 was the last section. 11.3 and 4 are about sequences and series, and we skipped over those. We're just working on the money problems. My electric pen. Okay, so we pretty much have one formula in this chapter section, which is annuities. And the formula is given to us in problem 3. Sometimes we'll solve for A, and other times we'll solve for M. If they ask us for, let's see how they word it. Just A equals there. Find the value of the annuity at the end, find the value of the annuity at the end. Sometimes I think it's just worded, find the value of the annuity, right? So it's a future value amount like we're used to seeing. So A stands for future amount. Some people call that future value. So definitely we can solve for that. Also, an easy enough thing to solve for, not easy, but easier than the other variables, is M, which is the regular payment. In some books, they call this R for regular payment, but I suppose I appreciate not having 2 R's. So M is the monthly payment amount. So we can also solve for that. First, we'll just solve for A. So the ordinary annuity formula is given, and they've given us M, the regular monthly payment. They've given us R to be 5%. They've given us T to be 8 years. And then we need N and NT. So N is the number of compounding periods per year. And since this is monthly, right, our number of compounding periods per year is 12 because of the monthly, and NT. So NT is 8 times 12, 96. And then it's just an act of getting things into your calculator correctly, right? So we have A is 50 times the parenthesis for the bracket, the parenthesis for the numerator, and then the parenthesis for the quantity, 1 plus, and I'm trying to write it like a calculator, so R 0.05 divide by 12 in parenthesis caret 96, and then subtract 1. Your calculator will recognize the order of operations. When you enter the subtraction, the calculator knows that you're no longer in the exponent. And then in parentheses for your ending the numerator, sorry. And then we have to divide by the denominator, which itself is R divided by 12 in parentheses, end parentheses. Now we should have as many parentheses starters as enders. So 1, 2, 3, 4 starts, and 1, 2, 3, 4 endings. So that's good. And then I'm just going to double check. That one's our numerator. That one's our denominator. And this one is the whole quotient that's being multiplied onto the 50. Okay, so now that we have it in calculator form, I'm going to write 50 times open, 1 plus 0.05 divided by 12 in parentheses, caret 96, subtract 1 in parentheses, divide by open parentheses, 0.05 divide by 12, end. So 2 ending parentheses. And I get as a result I get 5887 point, rounding up to the nearest cent, 3. So in the future, if we deposit $50 a month for 8 years into this account, at the end of 8 years, we'll have nearly $6,000, right? Well, $5,887.03. Okay. We can enter it if we wanted, so we don't lose it. All right, for number 4, same deal. They give us M to be 100. That's the regular monthly payments. They give us R to be 6%. They give us T to be 10 years. It's a monthly payment. So M equals 12. And oh, sorry, I'm used to calling the denominator M, so that was my fault. N equals 12, and then N times T is 120 for our exponent. Okay, so we type into our calculator 100 times a parenthesis for the quotient, a parenthesis for the numerator, and then a parenthesis for that quantity, that's 1 plus R divided by N raised to the power NT, take away 1, into parenthesis for the numerator, divide by the denominator, 0.06, divide by 12, in parenthesis for the denominator, into parenthesis for the quotient that's being multiplied onto M. And then enter this in, 100 times 1, 2, 3, 1 plus 0.06 divided by 12, end of parenthesis, caret 120, take away 1, end parenthesis, divide by denominator, so parenthesis 0.06 divided by 12, end parenthesis for the denominator, end parenthesis for the quotient. And I get a value of $16,387.94 for number 4. Find the value of the annuity at the end of the indicated number of years. Assume that the interest is compounded with the same frequency as deposits. Round your answer to the nearest cent. So here our M is 800. That's the regular deposit, but this time N is 1 because it's annually. And then the interest rate, right, is 0.01 of a time of 20 years, which is also an NT of 20. Okay, let's see. So now we just use our formula, right? A equals 800 times 1 plus 0.01 divided by 12 raised to the 20, take away 1 in the numerator, and our denominator is 0.01 divided by 12. And then you stick that in the calculator the way we have been. So 800 times 1, 2, 3, parentheses 1 plus 0.01 divided by 12, end parenthesis, caret 20, take away 1, end parenthesis, divide by parenthesis 0.01 divided by 12, end. I get the value oh, I messed up. I put 12s down there just out of habit. Good thing we've seen it in the stacked form, kind of, I think. Okay, so let me redo that. That's a divide by 1, which then doesn't really matter. Raise to the 20, and another divide by 1, which doesn't really matter, right? So we can, in fact, type in 800 times the 1 plus 0.01 raised to the 20, take away 1. I don't need a separate parenthesis for the denominator, but I'll leave it there just for convenience. And stick this in, 800 times this is a better answer. Okay, that looks better. Okay, so for 5, I got that A will be 17615 and 20 cents. So just sticking it in the calculator, right? And now we're starting to change up what the frequency is. So we're back to monthly on this one. And then we get some more problems, right? So here A equals 100 times 1 plus the rate divided by n, which is 12, raised to the nt. N is 12, and t is 6 times 12. So 60 plus 12, 72. So raise that to the power 72, and then subtract 1, and parentheses for the numerator, divide by parentheses 0.05, which itself is divided by n, and the quotient. Okay, so 100 times 3, 1 plus 8,376.43, rounding up to the nearest cent. Okay, self-employed persons can make contributions for their retirement into a special tax deferred account called a KEOG account. Suppose you are able to contribute 15,000 into this account at the end of each year. How much will you have at the end of 20 years if the account pays 2% interest annual, right? And so you have here, they're telling you that we're making this deposit, which the deposit is 15,000 each year. So the frequency is 1 for yearly, right? N equals 1 for 20 years. So NT is 20 for our exponent at a rate of 2% annual interest. And I think that's all we need. A equals M times the quotient of 1 plus R divided by 1. So we don't really need to divide by 1. Let me write that. raised to the power 20, right? Take away 1. And then we're dividing that quantity by 0.02. And that's the quotient that we're multiplying onto that 15,000. So 15,000 times okay, that gives me at the end of the retirement in number 7, 364,460 and rounding up to the nearest cent, 55 cents. So that's the answer for 7. And 8 reads, the owner of Sebastopol Tree Farm deposits $750 at the end of each quarter into an account paying 1.25% compounded quarterly. What is the value of the account at the end of 5 years? Okay, so here, let's clear this out. This time we have a regular payment of $750 into an account each quarter, paying a rate of 1.25% for 5 years for a total amount of compounding periods in T of 20. So that A equals 750 times the quotient of the quantity 1 plus 0.0125 divided by 4 raised to the power 20, take away 1, divide by the quotient of R, divide by N. Okay, so entering this into the calculator, 750 times 123 parentheses 1 plus 0.0125 divided by 12. No, sorry, I always do 12. I'm so on the monthly thing. Okay, divide by 4. Raised to the power of 20. Take away 1. In parentheses for the numerator. Divide by parentheses 0.0125. Divide by 4. End parentheses, in parentheses. I get the value $15,453.77. So that got 750 4 times a year. And after 5 years, it added up to 15,000. The owner of Oak Squirrel Farm deposits $3,000 at the end of each quarter into an account paying 1.5 compounded quarterly. What is the value at the end of 5 years, 6 months? Okay, so this is different because the time is different. So here we have regular payments going in of 3,000 each quarter, paying 1.5% for 5.5 years, which is a total amount of compounding periods of 22. We'll double check that. And then we enter this into the calculator. 3,000 times that 1 plus R over N raised to the NT, take away 1, divide by 0.015, itself divided by N. And then we enter this into the calculator. So 3,000 times infancy for the numerator. Here we get a value 6864.89. So far, we've just been filling out this formula repeatedly. Okay, so for number 10, a lottery offers a $1 million prize to be paid in 20 equal installments of 50,000 at the end of each year. What is the future value of this annuity if the current rate is 7%? Okay, so we have regular payments of 50,000. We have yearly payments that are being made. We have 20 of these payments being made at a rate of 7%. So NT is 20. That's our exponent, right? A equals M times 1 plus R over N, and we don't have to divide by 1, right? So we'll just write 0.07 raised to the 20, subtract 1, and then divided by the rate divided by N, which is 1. So 50,000 times parentheses 1.07 raised to the 20, take away 1, and parentheses for the numerator, divided by, yeah, I was a little uncomfortable about this one, but 20,000, oh no, wait, 2 million, sorry. I just got scrunched in over here, so I cut the number off of my brain, but let me try to rewrite it where I can actually read it. So two 049,774.62. Heck yeah. Sign me up for the annuity. Right, we just doubled. Thank you, Kansas Lottery. Okay. John and Rosamond want to retire in 5 years and can save 160 every 3 months. They plan to deposit the money at the end of each quarter into an account paying 6.72% compounded quarterly. How much will they have at the end of 5 years? M is the regular payment. T is the number of years. Let's see. N is the frequency of the deposits. R is the interest rate. And NT is the total number of compounding periods or deposits in this case, right? And then we just have our old familiar formula, M times 1 plus R divided by N raised to the NT, take away 1, and then that quantity is divided by 0.067. Eliza's not here. Divide by 4. 160 times it really is just an exercise in getting your calculator work right. I mean, of course, there's stuff to take away in terms of the math, but it's plucking the pieces out that you need, writing it in the correct manner so that you can get it into the calculator and get the answer out correctly, right? So a couple more of these, and then we'll start solving for M. So hopefully you got comfortable. Let's see, in 2012, the maximum Social Security deposit by an individual was $8,386.75. Suppose you are 31 and make a deposit of this amount into an account at the end of each year. How much would you have to the nearest dollar when you retire if the account pays 2% compounded annually and you retire at age 65? So they make you work for T, right? So T is 65, take away 31, so 34 years. N is 1, so NT is just 34, right? We also have a rate of 2% and the deposit amount, which is M838.6.75, and plug and chug, right? So we have M times 1.02 raised to the 34, take away 1, in parentheses, kind of crunched myself up here. Divide by R. So that's our formula, right? But 1 plus R over N is just 1.02, right? And here R over N is just 0.02. So when N is 1, we can write it more compactly, right? Times just 2 parentheses, 1.02. I probably don't even need that parenthesis, but it's just a habit. Take away 1, end parenthesis, divide by 0.02. And I get that at the age of 65, we would get to retire with $402,847.49, rounding up to the nearest cent. 13 reads, if you want to retire at age 65, you decide to make a deposit to yourself at the end of each year into an account, paying 4% compounded annually. Assume you're now 25 and can spare $1,500 per year. How much will you have when you retire? This one seems reasonable, right? The time is going to be 65, take away 25, so 40. We're told the frequency of these deposits is every year at a rate of 0.04, right? NT is just going to be 40, because 40 times 1 is 40. Let's see, M, the deposit is 1,500. And then we go for the plug and chug, right? So 1,500 times my numerator, 1 plus R over N is just 1.04. And then we raise that value to the NT, and then take away 1, end parenthesis, divide by R over N, which again is just 0.04. So if we enter this into the calculator, I get 142,538.27. Okay, so now if A is M times the quantity 1 plus Rn raised to the NT, take away 1, divided by the ratio of R over N, then we can solve for M, right? In an equation where we take A and divide by that quotient that we've been multiplying onto M. So now instead of M times this whole mess, now we're going to do A divide by this whole mess, right? So that is rewritten for you in your book using what they call the sinking fund formula, right, on page 554. So in the sinking fund, we're looking for M, right? So we need to solve for M now in that we do A divide by the stuff we've been doing, right? 1 plus R over N to the NT minus 1 divide by R over N. Okay, so for 16, we're told that A is 9,000. We have that N is 1. R is a 0.5 of a percent. Divided by 1, which we don't really need, but just to really fill out the formula the way it is. Okay, so if we entered this into the calculator, we would enter 9,000 divide by parenthesis 1.005 caret 7, take away 1, end parenthesis 4 numerator, divide by denominator. This should be a go. Okay, so let me try. 9,000 divide by parenthesis 1.005 caret 7, which is n times t, take away 1, end parenthesis, divide by 0.005, end parenthesis. I get the right answer, which is joyous. $1,266 and rounding up to the 56 cents. So that was 16 right there, right? And so now we just have to look at these other ones and change a little bit, right? But that's the pattern now. Now we do A divide by the quotient we've been doing. Okay, otherwise, semi-annual means N is 2. That means NT will be 30, right? And so for 17, let's just leave our formula there. Oh, I forgot to type in our answers. I did it like once and then I was like, we good. Okay, 70,000 divided by 1 plus 0.04 divided by 2 raised to the power of 30, take away 1, and our denominator is 0.04 divided by 2. I'm going to put into the calculator 70,000 divided by, let me see how many parentheses I need. 1 for the quotient, 1 for the numerator. The numerator is 1.02, caret 30, take away 1, in parentheses for numerator, divide by denominator, which I'm simplifying. And this is what I'm going to type in. Okay, so 70,000 divide by 12 parentheses 1.02 caret 30, take away 1 in parentheses, divide by 0.02 in parentheses. Yeah. Answer to 17 is 1,725, and rounding to the nearest cent, 49 cents. Check, check. So I think the key is just getting into a rhythm and not stressing over it too much. Clear that out. We'll go to 18. And 19 and 20, and we'll be done. And we're just doing the same thing over and over. It's just this time n equals 4, right? And t equals 36. The rate is a weird one, 0.014 in decimal form. And then we'll just type in our formula, which is the m equals a divided by that 1 plus r over n to the nt, subtract 1, divided by r over n. Okay, so m equals 75,000, not times, but divide by 1, 2, I'm going to go for 3 because I'm going to do the quotient slowly. 1 plus 0.014 divide by 4 in parentheses, caret 36, subtract 1 in parentheses, divide by parentheses 0.014 divide by 4 and end. Now let's count the opens. 1, 2, 3, 4, and the closing parentheses 1, 2, 3, 4. That's good news. Okay, now let's type this in. 75000 divide by 1, 2, 3, 1 plus 0.014 divided by 4 in parentheses, caret 36, take away 1 in parentheses, divide by parentheses 0.014 divide by 4 in parentheses, end parentheses, and check the answer. Then be super happy because we got 1,958, and rounding up to the 48 cents. So if we put in almost $2,000 4 times a year for 9 years, we'd be able to make $75,000 in this particular account. Is that a good deal? Is that a good deal? We're going to make 36 payments of $1,958 and 48 cents. So how much is that? Let's see. It's 70,000. So we made $5,000. Not too bad, right? It's all right. It's a low interest rate, but it is 4 times a year, so. Okay, let's look at our last two problems. Clear Lake Optical has a $50,000 note that comes due in 5 years. The owner wishes to create a sinking fund to pay this note. That's what we've been doing. If the fund earns 4.5% compounded semi-annually, how much must each semi-annual deposit be? Okay, so our future value of this annuity is 50,000. T is 5, right? N is 2. So N times T is 10. R is 0.045. And then we just fill in our formula, right? Where we have, well, we had that one to start with. And then we solved for M. Okay, so M is 50,000 divided by 1 plus 0.045 divided by 2 raised to the power of 10, take away 1, divide by 0.045, divide by 2. Stick this monster in there. And then check the answer and do a victory dance. 4514.38. Victory. Okay, our last problem. A business must raise 70,000 in 9 years. What should the size of the owner's quarterly payment to a sinking fund paying 4% compounded quarterly? What should that be? Okay, quarterly means we have a frequency of 4 times a year. A rate of 4% is 0.04. Right? We have T equals 9 years. So we have an exponent in T of 36. R over N is 0.01. And 1 plus R over N is 1.01. So when we write our formula, we can say M equals 70,000 divided by 1.01 raised to the exponent 36. See, I like in calculator form there better. But maybe if I write a little larger. 0.01 raised to the 36, take away 1, divide by 0.01. Okay, so entering this into the calculator, 70000 divide by parenthesis, 1.01 caret 36, take away 1, end parenthesis, divide by 0.01, end parenthesis, and we get $1,625, rounding to the nearest cent. No cents. And we're done. This is a difficult chapter, mostly because of the formulas. It's really an act of getting your calculator work right. In the first questions, we solved for A, and in the second group of questions, we solved for M, right? We just did the same thing repeatedly in this exercise. So hopefully by the end of it, you've got a rhythm for the calculator work. And if you have any questions, let me know. I've got drop-in hours. Monday and Thursday, 2 to 3. Monday and Wednesday, 6. $7:15. So if you have any questions, please just let me know. Have a good week.